Everybody, welcome to another episode of Analytics Mindset. In this video, we will look into date and date time manipulation. Dates are a very important part in SQL. It is one of the biggest default filters you're gonna have. It's just easy to filter on dates. They are very easy to comprehend. They are difficult to manipulate. I will say that, as you will see soon here. But this is going to be a shorter video to introduce you to dates. There is a lot of stuff you can do in dates. There is a lot of manipulations. There is a lot of converting, casting, etc. This video is just going to introduce you to the main concepts of dates, right? In BigQuery specifically, we will start by doing that. Some other database technologies and implementations have a different way of interpreting dates. It's usually standard, but keep in mind that some formulas here may or may not work depending on which platform you're using. Again, I'm defaulting to BigQuery, but you may want to double check if you're just copy pasting code that the code is applicable. Let's start with dates. What's so important about dates? If I do this, you might be surprised that I can just get something without a from statement. That's because I'm telling BigQuery, hey, just give me these things. I'm saying, give me this value as this column, this value as this column, and these two values as this column. It is very easy for BigQuery to do that because it is technically not a relational database. That is a whole discussion. It is more of a data warehouse and a data lake, but that is out of the scope of this video. Just know that BigQuery allows you to do this, and it's easier for me instead of creating a whole table or extracting the dates of an actual sample database and then playing around with them. That I could, but I want to show you from visual perspective how it looks like. I have four kinds of four dates and two different kinds of them. You can see that the string date is actually just a string. I'm taking the string, I'm saying today 250401, by the way, that is the usual format that you will use in databases by default. You can use month, date, year, but 95% of the world uses day, month, year, or the other way around, year, month, date in this case. That is a standard everywhere. If you want to use month, day, year, or the other way around, there will be year, day, month. You will need to specify it yourself. Yes, keep that in mind. You have the string date, the past date, the real date, and the real past date. They might look the same for you when you are looking into the database result. If I downloaded this to CSV, I wouldn't see any difference between them. That's because dates are built on strings. There is a lot of more complicated stuff that goes into it, but strings are more general than dates usually. You can cast a string to become a date. But on other one, you can cast a date to become string. All dates can become strings, but not all strings can become dates. I just put this to 250401. We talked about strings before in BigQuery. In databases in general, string is just any kind of text. String is more general than dates, and you will see why that matters later on. The function cast allows you to take that string and convert it into an actual date. And even though you don't notice a difference, there is a big difference between the first two and the last two dates here in the columns that they are contained on. If we want to calculate difference, we can do this. So what I'm gonna do is, because this is inside a CTE, I'm gonna need to take it out of the CTE. And we will just do this really quickly. You can see here how I got this very weird format. That just means there is 12 days of difference. That is the actual difference between these two. Now, if I try to do it on the first two, you will see that there is not much in signature. BigQuery is basically telling you, I don't know how to subtract a string from a string. And that is what you will get if you did any other two random strings. You can do int to int. integer to integer, that's the usual default. You also have numeric, floats. You can see that dates, timestamps, and date and intervals are allowed, date times too, but not just a conversion between date and string. And that is intentional. Why can I not do that? Because, again, BigQuery just doesn't know how to take a string and subtract it from a string. By converting them first to string into the cast function, you are able to actually say, hey, you are a date. I want you to take from this date to this date. And BigQuery has a ton of functions to manipulate dates. I'm not going to cover all of them in this video. Yes, no, there's a whole universe of functions there that half of them, I would say, probably are just focused on converting edge cases of strings into dates. You could tell BigQuery 5 days and convert that into an interval. Or if you want to add a day, there is very funny ways that you can do that. Just for your general knowledge there. We're going to follow up with a day's example. So in this day's example, you can see that I have a difference. I'm taking a difference, I'm extracting that day into here from a difference, and then I have the current date time, the difference, the date I'm converted, and I will just go to each of those things really quick. And the reason why I need to do this is because it's inside that CTE, it's not going to allow me to do it directly. And it is not allowing me because I have this base example and I need to select all from this example. There you go. And I'm just gonna return the script to the original form. As always, I will provide you the script. If you want to play around with it, you can do it. The only thing you won't need to change anything because I'm not referring any custom data set that I have. I am just using the BigQuery public data and those values here that are hard coded into it. What is this? First, we have the difference. The difference is nothing more than an interval. It is saying there is 12 days, but it is in the date time form. It will have, as we saw before, the day, the year, month, day. Then we'll have hours, minutes, seconds. That is the usual format of datetime. That's why it looks like that. The function extract has a lot of uses to BigQuery. Again, you can store JSON in BigQuery. That's a huge use of extract. But for this particular case, you can get out those 12 days as an actual 12. If you were to do something like, let's just say, take me the difference of these days and then do an average, you can't do an average on this thing. You can actually, you could build a custom function that converts it and all, but extract is already in BigQuery. Why reinvent the wheel? You have a function that will just take those number of days into 12, it will return it as an integer, and you can do the average by yourself there. Just call it average there. You can call multiple parts of it. There is a lot of other things you can call onto the function, but just to show you, day is part of it. You can extract the number of days from a date time difference. The function current date is one of the most useful ones out there. It allows you to return the day of today. As I'm recording this video, it is May 4th, 2025. Date time does exactly the same thing. The current date time function just gives you the current date. You can see there it's exactly the same, but it adds the time. It is in UTC time, so when I executed this was around what? 4:25 UTC, and you can see the seconds and milliseconds are too. The current difference, I'm just subtracting current date time from current date. You will see that it's just the same. It is just gonna return me the time side of date. It's not gonna return me anything else more than that. And finally, if I just get the cast current date time as date, I will just get the current date. That's all I'm gonna get. I won't get anything else more than that. Okay, that is it for there. The next part we're gonna see is after saying all of that, why are they useful? There is multiple case uses. Filters are by far one of the biggest ones that I will show you here today. But you can also do between, basically saying between this day and this date. And usually when you're working with big data sets, I would say more than 1 million records, it is almost always recommended that you start with a date subset. You can make like the last 7 days. Show me the last 7 days, the last 19 days, the last 5 days, etc. Whatever it's the case for your own business specific use. You should not be querying millions of records just to get a nice EDA or getting a hang of what information you need. They also allow you to pivot and group by into summaries way more efficiently because you don't need to filter them out later on. You can just say, all right, this report has a sales between this and then I just going to group by here and have my total sales for this period of time. Then, if you're also taking this out from BigQuery to, I don't know, let's just say a data warehouse, whichever you use, or you are writing it to BigQuery too. There is a lot of use cases from Azure, from S3, etc. You want to limit your data to what you need. You should not be doing a select star on everything. It's gonna be very expensive. I assure you, it's gonna be very expensive. You should be filtering at least on a day. It's like, do I really need, let's say the database has 10 years of data. Do I really need all those 10 years of data? The answer 99% of the times is going to be no. We want this report only for these 2 weeks. We want this maybe a year, 3 years, let's say 5 years. A lot of, a huge part of reports being created out there or etc. Unless you're just looking at the whole table, you are never going to be retrieving all data. You will always be retrieving a subset of the data, prefer some date, and then you're going to apply other filters on it. That is my 2 cents there. You should always have at least some kind of date filter. If it's an EDA, yes, for sure, you should at most 3 days of data, maybe. If it's not an EDA, whatever is relevant to your analysis, you shouldn't be just taking the whole database and doing the analysis on all of it and then filtering it because this is one of the best use cases for database administration and database knowledge. You can filter out and make your life easier down the road than just trying to import like I don't know 3 million rows into Excel and then Excel itself is struggling just to filter something. The last part is gonna be showing you this GitHub data, how I'm filtering it out. So how do I read this? You are gonna select everything from the GitHub timeline. It's a public data set repository that you can actually see too. I am doing repository created at is not a date. It is a string. I needed to convert it to date. So why you see it here is because it's in the correct format as datetime. I was able to convert it to a date. Then I'm saying it needs to be within current date and 14 days from 14 years from today in the past. 2025 all the way to 2011. That's filtering a good chunk of the data set because I think the data set goes all the way to 2008 or something. I'm just taking the last year of it. I'm saying that I only want then whatever repository language is Python only and when the repository description is not empty. If I were to get rid of this filter, you can see there is around 301,000 records, 100,000. And we're just gonna compare it when if I get rid of that filter and see how much I get. I'm gonna get a lot more data, I can tell you that. You can do year, you can do date, you can do a lot of stuff. There you go, 415,000. I filter quite a lot, but again, this is not a big data set. It is a relatively small. But yeah, that is pretty much all for today. This was an introduction to date and datetime. For sure, use it when you're filtering it. basic EDA, you should be able to say, hey, I only need 14 days of data, I need 28, I need this, I need that. You'll be surprised how much of a difference it will make in your queries when you are doing ad hoc analysis. When you're doing more established analysis or schedule analysis that needs to be done multiple times, you need to define that date range correctly. But again, I assure you, no one wants a dashboard that has 10 days of data unless you are doing an analysis on the tables themselves. Current data is or close to current is way more valuable. This year's data is the thousands of times more valuable than today's data. And let's not talk about COVID because COVID screw up a lot of long-term trends all over the place and makes historical data even less relevant. And as a data analyst, that's a big chunk of your job. Define what's important and what is not. That is something that I may touch more in the future if you guys would be interested. But all right, that is all for today. As always, leave me comments, recommendations, and I will see you in the next video. Thank you.